Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry Chapter 8, Section 1, Part 1b. And what we're going to do today is to learn how to name ionic compounds with transition metals. So transition metals have multiple charges, so they can form multiple compounds. So this is kind of what we've been talking about. Right here we've been looking at them and I'm like, well, sometimes they're a 1 and sometimes it's a +2, and now we're gonna kind of be looking more into those oxidation numbers. Okay, so let's look at our periodic tables and we'll look at iron. And if you look at iron, its most common oxidation numbers are 3 and 2, and these are positive because they're metals, so +3 and +2. Well, if you have a +3 charge, and oxygen is a -2 charge, then you're going to need 2 irons and 3 oxygens, because +3 and +3 is +6, and then -2 and -2 and -2 is -6, so that will equal each other out. So this is iron if it has a +3 charge, but it could also have a +2 charge, and so if it's a +2 charge and oxygen is a -2 charge, they balance each other out, so it's just a 1-to-1 ratio. How do we know if iron oxide is this one or this one? Because they're totally different compounds. Well, we tell people with a Roman numeral. So you put the charge of the transition metal in a Roman numeral in parentheses just after the name of the metal. So let's look at an example. Let's do lead. Okay, so we have to do a little bit of figuring things out. So lead is balanced with 2 chlorines, and we know chlorine has a -1 charge. So if there's 2 of them, it's -2. So what? -2 equals 0. Well, that's +2. We see that since the chlorine had to be -2, the lead has to be +2. I look at my periodic table, and 2 is a common oxidation state for lead, so that's great. So now I'm going to put a Roman numeral in parentheses right after the name of lead. And it looks like this, lead 2 chloride. So just remember, this 2 is the charge of lead. It's not how many there are, it is the charge. Okay, so let's do one more together and then I'm going to have you do some. Alright, so let's think through the charges on this one. So phosphate, we know, has a charge of -3, and there's 2 of them, so that would be -6. This side is -6, so I know this side has to be +6. So it doesn't mean that iron is +6, it means 3 irons are going to be +6. Well, what times 3 equals 6? 2, so this has to be +2. So iron with a charge of +2, and times 3 because there's 3 of them, equals +6. And then on our periodic table, can iron be a +2? Yes, it can. That's one of its common ones, and I know that because it's in bold. And then I put a Roman numeral 2 because that is the charge on iron. It's not the number, it is the charge. And then remember, phosphates, you just write the name of the polyatomic ion. Well, I'm going to have you practice this a little bit. There's that one, and that FeO, and Fe2O3. All right, that's the end of 8.1. Good job. See you later.